Hi students, welcome to Sunil's tutorial. I am Sunil Nirvani and today we will be doing this chapter of physics called as wave motion. Please take down some guys. A tuning fork produces 6 beats per second. A tuning fork produces 6 beats per second with a sonometer wire. A tuning fork produces 6 beats per second with a sonometer wire when it is 95 centimeters long, when it is 95 centimeter long or 100 centimeter long. When it is 95 centimeter long or 100 centimeter long. Find the frequency of the tuning fork. Find the frequency of the tuning fork. Now guys, we know that frequency is inversely proportional to the length of the tuning fork. Here I can say that L1 is less than L2, L1 is 95, L2 is 100, in which case I can therefore say that N1 has to be greater than N2 because they are inversely proportional. If length is small, then frequency is going to be greater, right? Now let us assume they've asked you that a tuning fork produces 6 beats per second with a sonometer wire. Let's assume that let N be the frequency of the tuning fork. Now if N is the frequency of the tuning fork, then I can say that N1 is the largest frequency. If I want beats, I should know which is the largest frequency and which is the smallest frequency. That means N has to be between N1 and N2. Now they are saying that it produces 6 beats. It produces 6 beats. If it is going to produce 6 beats, that means larger frequency minus smaller frequency should be 6. That means N1 minus N is going to be 6. Also, I can say that N minus N2 should also be equal to 6 since it is producing 6 beats per second. Now from the first equation I can say that N1 is N plus 6, and from the second equation I can say that N2 is N minus 6, right? Now once I have this, we know that N1 L1 should be equal to N2 L2. Frequency into length is constant, guys. Right in the beginning I had shown you that frequency is inversely proportional to length. So if I take this here, I'll get N1 L1 is equal to N2 L2. You have the values. N1 is N plus 6 into L1 95 is equal to N minus 6 into L2, that is 100. You can solve the equation and get your answer, right? When you open the bracket, you can solve the equation and get the answer, in which case you will get the answer for this as N is equal to 234 Hertz. Right? Take down next one please. Take down the next one please. Two tuning forks when sounded together, give 4 beats per second. One of them is in unison. One of them is in unison with a length of 80 centimeters and the other with 81 centimeters of the same wire. Determine the frequency of the fork. Determine the frequency of the fork. Determine the frequency of the fork. Okay, here you've got two different tuning forks. Now first of all I can say L1 is less than L2, L1 is 80, L2 is 81. Therefore, N1 frequency of the first fork has to be greater than the frequency of the other fork. Moreover, they said that it produces 4 beats per second. That means I can therefore say that N1 minus N2 is going to be equal to 4. Therefore, I can say that N1 is N2 plus 4. Also, I can say that N1L1 is equal to N2L2. Right? NL has to be constant. So N1, that is N2 plus 4 into L1. L1 is 80, is N2 into L2, 81. N2 is the only unknown. When you solve the equation, you will get the value of N2. Once you get N2, you can substitute N2 here and get the value of N1. The answer for this should be 320 Hertz and 324 Hertz. Next, take down next one please. A set of 11 tuning forks. A set of 11 tuning forks is kept. A set of 11 tuning forks is kept in ascending order of frequency. A set of 11 tuning forks is kept in ascending order of frequency. Each tuning fork gives 5 beats per second. Each tuning fork gives 5 beats per second with the previous one. Each tuning fork gives 5 beats per second with the previous one, and the frequency of the last tuning fork is 1.5 times, and the frequency of the last tuning fork is 1.5 times that of the first. Find the frequency of the first, last and the seventh fork. Find the frequency of the first, last and the seventh fork. Find the frequency of the first, last and the seventh fork. Now guys, this is a rather important question. Let's see this. They generally ask you this kind of numerical in the paper. Let us assume that let the frequency of first fork equal to n. Frequency of the second fork n plus 5, because it's giving you 5 beats per second. So this can be written as n plus 2 minus 1 into 5. Frequency of the third fork will be nothing but n plus 10. So I want to change 10. So this will be 3 minus 1 into 5. 2 into 5 is 10. Now if frequency of the second fork is 2 minus 1 into 5, frequency of the third fork is 3 minus 1 into 5. So frequency of 11th fork is going to be n plus 11 minus 1 into 5. They have also given you that the frequency of the 11th fork, that is n plus 11 minus 1 into 5, is 1.5 times the frequency of the first fork. Right? Now I can solve this equation. If I solve this equation, I will get this as n plus 50. 10 into 5, that's 50, is equal to 1.5 n. You can take n on the other side. 50 is equal to 0.5 n. Therefore, n is equal to 50 upon 0.5. Right? So you will get the value of n to be 100 Hertz. So frequency of the first fork is 100 Hertz. Frequency of first fork is 100 Hertz. Frequency of last fork is 1.5 N. So that's 1.5 into 100. That's 150 Hertz. And they've also asked you to find out frequency of the seventh fork. Frequency of seventh fork is N plus 7 minus 1 into 5. So N we know is 100 plus 6 into 5. So 130 Hertz. Right? That's how you can find the frequency of any given fork. Right? Let's do another sum of this kind. Take down next sum, please. A set of 33 tuning forks. A set of 33 tuning forks is arranged. A set of 33 tuning forks is arranged a set of 33 tuning forks is arranged in the order of decreasing frequency. In the order of decreasing frequency. In the order of decreasing frequency. Any one of them gives x beats per second. Any one of them gives x beats per second. Any one of them gives x beats per second with the previous one. If the frequency of the first fork, if the frequency of the first fork is an octave of the last, find x, and also find the frequency of the first and the last fork. Find x and also find the frequency of the first and the last fork. The frequency of the 10th fork, is 440 Hertz. The frequency of the 10th fork is 440 Hertz. Right? Now, if you go through the previous sum, you should be able to follow this, guys. Okay, let's see this. Let the frequency of the first fork. Let us assume that the frequency of the first fork is n, right? Now, since it is arranged in the descending order, the frequency of every subsequent fork will be less than that of the first one. They've said that the tuning forks are arranged in the order of decreasing frequency. That means frequency of the second fork has to be less than that of the first fork. Now they are saying that the number of beats are x, right? It gives you x beats per second with the previous one. That means the frequency of the second fork will be less by x. This can be written as n minus 2 minus 1 into x. X can be written as 2 minus 1 into x. Similarly, the frequency of the third fork can be written as n minus 2x. This can be written as n minus 3 minus 1 into x. If the frequency of the second fork is n minus 2 minus 1 into x and the frequency of the third fork is n minus 3 minus 1 into x, I can therefore say that the frequency of the nth fork, or nth, no, here they give you 33. The frequency of the 33rd fork is going to be n minus 33 minus 1 into x. That gives me the frequency of the 33rd fork. Now they've said that also the frequency of the first fork is an octave of the last fork. Frequency of first fork is octave of last fork. Right? Now in that case, what does that octave mean? It means that the frequency of the last fork, that's n minus 33 minus 1x, is going to be equal to half of that of the first fork. First fork is n. Octave means the frequency of the last fork is double that of the first fork. Fine, do we get this? So if I solve this, I'll get n minus 32x is equal to 1 upon 2n. Take this on the other side. So n minus 1 upon 2n is 32x. So you will get 2n minus n, that is n upon 2 is 32x. Therefore you will get n is equal to 64x. Right? They have also given you that the frequency of the 10th fork is 440 Hertz. Now what would be the frequency of 10th fork? The frequency of the 10th fork will be n minus 10 minus 1 into x, which is given to you as 440 Hertz. So 440 is n minus 9x. 440 is equal to n minus 9x, in which case I will get this as x, n can be written as 64x. We just found out the value of n to be 64x. So you can say that 440 is 64x minus 9x. 440 is equal to 55x. So x is equal to 440 upon 55. Someone please help me get this. I presume this should be equal to 8. That means the forks are arranged in the descending order and give 8 beats per second. Right? Once I have this, then I can find out whatever they've asked me. They've asked me to find out the frequency of the first fork. Frequency of first fork is n, and n is nothing but 64x. So that will be 64 into 8, which is going to be 512 Hertz. What else have they asked me? Frequency of the last fork. Frequency of last fork is nothing but frequency of the last fork is n minus 33 minus 1x. So n is 512, we just found out, minus 32 into 8. Right? So in that case you will get this as 256. So the frequency of the last fork will be 256 Hertz.
So,
right? Yes.
Why the first fork has n into x? Should be n.
N into x, it is n. And what's the value of n? 64x. Okay. Take on next one please. A car is moving. A car is moving at 54 kilometers per hour. A car is moving at 54 kilometers per hour. Sounding its 500 Hertz horn. Sounding its 500 Hertz horn. A car is moving at 54 kilometers per hour, sounding its 500 Hertz horn. What is the frequency heard by the person? What is the frequency heard by the person standing at the roadside? Standing at the roadside as the car, standing at the roadside as the car, first part of the question, approaches him. First part of the question, approaches him. Second part of the question, recedes from him. Second part of the question, recedes from him. Given that the velocity of sound in air, given that the velocity of sound in air is 330 meters per second. Given that the velocity of sound in air is 330 meters per second. Now first thing, let's find out the velocity of the source. Velocity of the source is given to you as 54 kilometers per hour. First let's convert this into meters per second. Multiply by 1000, divide by 3600. That will give you those many meters per second. So you know now the velocity of the source. You also know the velocity of sound in air. Now the first part of the question, they are saying that the source approaches a stationary observer. Right? Now if the source approaches a stationary observer, the apparent frequency that the observer would hear is V upon V minus Vs into N. You know V, you know Vs, you know N. You can substitute the value and get the answer for this. Right? You've done this. Second part of the question, as the source receives a stationary observer. So the apparent frequency that the observer would hear would be V upon V plus Vs into N. So all you have to do is just substitute the values in the formula and you will get your answer. The answer for this should be equal to 523.8 Hertz and 478.3 Hertz. Right, take down next one please. A fixed source emits sound. A fixed source emits sound of frequency. A fixed source emits sound of frequency 1000 Hertz. What is the frequency heard by an observer? What is the frequency heard by an observer? What is the frequency heard by an observer? First part of the question, at rest. Second part of the question, moving towards the source. Second part of the question, moving towards the source with a constant speed of 20 meters per second. Moving towards the source with a constant speed of 20 meters per second. Third part of the question, moving away from the source. Moving away from the source at a constant speed of 30 meters per second. If the velocity of sound in air is 330 meters per second. If the velocity of sound is 330 meters per second. Now guys, in this sum they haven't specified anything about the source. That means the source can be assumed as stationary. Now, first part of the question, if the observer is stationary. The source is stationary, the observer is stationary. That means in that case the observer would hear the true frequency. Right? Since none of them is moving, the observer will end up hearing the true frequency. Second part of the question, moving away from the source at a constant speed of 20 meters per second. The velocity of the observer is 20 meters per second. If observer moves away from source. If he is going to move away from the source, then the apparent frequency that he will hear is V plus V0 upon V into N. You have all the values, you can substitute and get the answer, right? Third part of the question. Moving away from the source at a constant speed of 30 meters per second. Moving away from the... No, in this case moves... Second part of the question is moves towards the source. Right? Second part of the question was if the observer moves towards the source. In that case, the apparent frequency is going to be N bar is V plus V0 upon V into N. Next, in the third part of the question, he is moving away from the source at 30 meters per second. So if observer moves away from source, so apparent frequency that he will hear is V minus V0 upon V into N. That will be the apparent frequency. All you have to do is substitute the values and get the answer. The answer should be 1059 Hertz, and the next one should be 911.8 Hertz. Right? Take on next one, please. Two trains are moving with a constant speed. Two trains are moving with a constant speed of 90 kilometers per hour and 72 kilometers per hour. Two trains are moving with a constant speed of 90 kilometers per hour and 72 kilometers per hour. The frequency of the whistle of the first train, the frequency of the whistle of the first train is 800 Hertz. The frequency of the whistle of the first train is 800 Hertz. Calculate the apparent frequency of the whistle. Calculate the apparent frequency of the whistle as heard by the observer. Calculate the apparent frequency of the whistle as heard by the observer sitting in the second train. Sitting in the second train if first part of the question, the two trains approach each other. The two trains approach each other. Second part of the question, the two trains move away from each other. The two trains move away from each other. The third part of the question, the first train follows the second train. The first train follows the second train. And the last part of the question, the second train follows the first train. The second train follows the first train. Now the frequency is being sounded by the first train and the observer is in the second train. So we can assume the velocity of the first train to be that of the source and the other train to be that of the observer. Now Bs is given to you as 90 kilometers per hour. Convert that into meters per second. Multiply by 1000, divide by 3600 meters per second. VO is 72 kilometers per hour. Multiply by 1000, divide by 3600 meters per second. Right? The actual frequency of the horn of the first train is 800 Hz. Now, the first part of the question. If the two trains approach each other, if the two trains approach each other, if the two trains approach each other, that means the source and the observer are moving towards each other, in which case the apparent frequency will be, since the observer is moving towards the source, V plus VO, right? Since the source is moving towards the observer, this will be V minus Vs into M. Right? So that will be the apparent frequency if the two trains approach each other. Next, if the two trains move away from each other, if the two trains move away from each other, if the two trains move away from each other, the V has to be the velocity of sound in air. I don't think I dictated that. Just write this down. The velocity of sound in air. The velocity of sound in air is 332 meters per second. The velocity of sound in air is 332 meters per second. The velocity of sound in air is 332 meters per second. Okay, let's see this. The two trains are moving away from each other. Moving away. That means this will be observer is moving away, V minus V0. Source is moving away, V plus Vs into N. So this will be the apparent frequency if the two trains are moving away from each other. Next, the third part of the question. If the first train follows the second train, if first train follows the second train, now if the first train follows the second train, that means the second train is moving away. If the second train is moving away, that means the observer is moving away. The first train is following the second train. That means the source is moving towards the observer. Source is moving towards the observer. That means this will be V minus Vs into N. Right? Next, fourth part of the question. If the second train follows the first train, if second train follows first train, apparent frequency. If the second train is following the first train, that means the observer is moving towards the source. If the observer is moving towards the source, that means this will be V plus V0. The second train follows the first train, that means the source is moving away from the observer. Since the source is moving away from the observer, this will be V plus Vs into N. So those will be the apparent frequency in the four cases. Fine, do we get this? In each of the case, the answer should be, in the first case, the answer should be 917.3 Hz. In the second case, the answer should be 699.2 Hz. In the third case, the answer should be 813 Hz. And in the last case, the answer will be 788.8 Hz. Fine? Right. This finishes this chapter. We will stop this here for the day. Thank you very much.